Hello everyone. We are going to take a few minutes to look over this lab and just double check that everything makes sense to you. So first of all, you should have a hypothesis written for 1, 2, and 3. And as always, make sure that you write a good because. That's the part that I'm really paying attention to. You should have a complete data table, and you should have answered question number 6. You should have a second complete data table, and you should have answered question number 12. You should have had a third data table complete here and answered question number 19. Of all of the data, the one you should notice that actually affects the period is the length of the string. So your answer here should say yes, as the string length increases, the period, and then you get to tell me what your data says. So as the string gets longer, what happens to the period? Okay? All right. So then we're going to look at our application problems here. And number 20, use the conclusions above to write a formula for the period of a pendulum. So what we noticed from our data is that the mass doesn't matter, the potential energy doesn't matter, but the length of the string does matter. And so when we write our formula, this is going to look really familiar to you if you did the reading or you watched the Ed puzzle. When we write our formula, it's going to look like this. T, right, the period of the pendulum, is equal to 2 pi, and you're going to say to yourself, why is there 2 pi in this formula? Well, think about that swinging pendulum as part of a circle, right? If it were to go all the way around, it would make a circle, so we're going to have 2 pi in there. And then the square root of L stands for length, over G. G, of course, is acceleration due to gravity on whatever planet you're on. So if you need a little reminder for yourself, T is the period. We want our period in seconds. L is length. We want our length in meters. And G on Earth is 9.8 meters per second squared. If you were to take your pendulum to the moon, for example, it wouldn't be 9.8 anymore. Okay? All right. So now that we have the basic formula, now we're going to rearrange it so we can solve for some other things. So if I want to solve this formula for G, here's how the algebra works. We start off with our basic formula. Also, I want to point out to you that that square root sign goes over the L and the G. Okay, that's not just on the top. So when you write this formula, write it carefully. Okay, so we want to solve for G. We want to get the G all by itself. So the first thing I'm going to do is square everything to get rid of that square root sign. So this is going to cancel out that. But I also have to think of it as going with the 2 and the pi. So after this step, what I'm going to have is t squared equals 4, right? 2 squared is 4. Pi squared times L over G. All right, so all I did was get rid of the square root sign. Now I'm still trying to get G by itself, so I'm going to move it out of the denominator. So I'm going to multiply both sides by G. That cancels. And now what I'm going to have is t squared times G equals 4 pi squared L. Last but not least, we're going to divide both sides by t squared, right? That's going to give me G by itself. And I'm going to end up with G equals 4, forgot the 4, pi squared times L over t squared. So if I were to give you the length and the period, you could find the acceleration due to gravity on a different planet. Okay. All right, we're going to do this one more time. This time we're going to solve for L. So we're going to start again with our formula. T equals 2 pi square root L over G. Just like we did last time, we're going to square both sides and get rid of that square root sign. That's going to give me t squared equals 4 pi squared L over G. Okay, so I need to solve for the L now. So I'm still going to multiply both sides by G. I'm trying to get L by itself. So I have t squared times G equals 4 pi squared L. Now I'm going to divide both sides by 4 pi squared. You could do that in 2 steps and divide by 4 and then divide by pi squared if you wanted to. This is faster. And I'm going to end up with L equals t squared times G over 4 pi squared. So if I were to give you the period and the acceleration due to gravity, you could figure out how long the string length is for a pendulum. All right? So for problem 23 here, on part A, you have that in your notes, so you can go back and label that pendulum. For part B, it asks you to calculate the acceleration due to gravity. All right? And up here in the first problem, it tells you the period is 4.5 seconds and the string length is 2 meters. So if we look back up at what we solved here, the formula that we need to use is this. Right? This is the one that's going to help us find G. Okay, so I'm going to ask you to finish part B here on your own, and we will look at it next time in class. Go ahead and hand the lab in with the rubric today, and then I will hand it back to you next week, and we'll take a look at part B here and make sure that we're all good. All right, if you have any questions, send me an email, or I should be around after school for a little bit. You can come back and find me. Thanks so much, and I'll see you soon.